Hi, welcome to part 2 of the capsule and video series about impulse and momentum. In the previous video, we have defined an impulse by giving two real-life examples showing the importance of it. In this video, we are going to start playing with the formula of impulse to understand where the formula and definition of a momentum of an object is coming from. At the beginning of this video, we are going to do some maths by manipulating the formula of impulse. You are completely free to skip this part and jump straight to the part where we give definition of the momentum by clicking on the timestamp in the description. Let's imagine an object moving on a surface with an initial velocity of vi under an influence of a net force. After a certain time interval delta t, the velocity of the object will become vf for v final. We can recall that the impulse applied on this object is equal to net force times delta t. According to the second law of motion, net force can be written as mass times acceleration of the object. And acceleration is the change in the velocity of an object in a unit time. Delta t's in this equation will cancel each other. As a result, impulse, which is f net times delta t, is equal to mass times delta v. As we know, delta means final value minus initial value of any quantity. In this case, it will be the final velocity minus initial velocity. If we distribute mass inside the parentheses, impulse will be equal to mass times final velocity minus mass times initial velocity. The expression mass times velocity in this equation is known as the momentum of an object. If we are going to write down the formula on the screen in words, we get the definition of the momentum. Momentum of an object is equal to the product of the mass and velocity of the object. Momentum is also a vector quantity and it is acting always in the direction of the velocity of an object. Unit of the momentum is same as the unit of an impulse. It is kilogram meters per second or Newton times second. Now let's solve a couple of simple examples about momentum. In the first example, we are asked to calculate the momentum of a car of a mass of 1000 kgs moving east at a velocity of 8 meters per second. In a capsule-aligned exams, this type of questions are generally for 3 marks. The first mark is for writing the correct formula, the second one for correct substitution, and the last one is for the correct answer. Momentum is equal to mass times velocity, where mass is 1000 kgs and the velocity of an object is 8 meters per second. Momentum is equal to 8000 kilogram meters per second. We are not done yet as momentum is a vector quantity, so we have to specify the direction of momentum as well. Momentum of the object is always in the direction of the velocity. Object moves east, so direction of the momentum is also east. In the next question, we are asked to calculate the magnitude of the change in the momentum of a car of mass 1200 kilograms if its velocity has been increased from 15 meters per second to 25 meters per second. We start solving the question by typing a formula. Change in the momentum is delta p, which means final momentum minus initial momentum of an object. Momentum of an object is equal to mass times velocity. Mass of the object is 1200 kgs. Final velocity is 25 meters per second and initial velocity is 15 meters per second. Change in the momentum is equal to 12,000 kilogram meters per second. In this video, we have manipulated the formula of impulse to understand where the formula and definition of a momentum of an object is coming from. Then we have solved two simple examples related to the momentum. In the next video, we are going to revisit the second law of motion and learn its relation with the impulse or momentum. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.